Hey everybody, welcome to Seattle, Washington, home of the University of Washington and also home to longtime professor Darrel Cowan. We're going to talk about Baja BC again, not with Merle Beck, but this time with Darrel Cowan, bedrock geologist, structural geologist. The saga continues. Let's head over to Darrel's backyard, see what he's got to say. Thanks for joining us. Let's get started.
Yeah, I've lived here 41 years in November. Yeah, it's close to the U and a bike trail where I can bike in when the weather's good.
Sure. When did you arrive here at the University of Washington?
I came in September of 1974 and never looked back. It's been a great place, great colleagues, good geology, good students, so I've enjoyed it the whole time. And I'm emeritus, but I still come back and teach winter quarter and our summer field courses if we could actually have them, but they were virtual this summer, but I participated. So I like the environment, I like my colleagues, and I love to teach my winter quarter structure tectonics class.
God, that is an inspiration, I'll tell you that, 1974.
Yeah.
And can you summarize your specializations in that almost 50 years worth of time at the UW?
Yeah, I think they hired me as a structural geologist, and I think my specialties, I'm a field geologist, and I think my specialties are structural geology and tectonics, larger movements of crustal blocks, and I'm a field geologist, so I like to go look at evidence in the field for, to solve problems basically, and not just geologic mapping, but anything else that could help, like petrography, isotope geochemistry. But so yeah, I'm a field structural geologist. That's how I'd classify myself.
And did you stumble into geology like the rest of us, and where did you go to school?
Well, I was born in Los Angeles. I'm a Californian, so that becomes important later in this interview. Right. And I was born in LA and grew up in the San Gabriel Valley, where I lived until I went to Stanford as an undergraduate in 1962. That's a long time ago.
Heaven's sakes.
I had a really rough first year, but the first quarter of my sophomore year, I took Geology 1 at Stanford, and I knew this was it. I collected minerals as a kid. I liked minerals, but there was something about the way it was taught, and the next 4 years at Stanford, one of their features was a lot of field trips. They took us out in the field, and the culmination was Bob Compton taught summer field geology in 1965. We had a 2-week siege in the California Coast Ranges, and then we went to Utah. And that, I think, made me, it really shaped my whole career. So then I went to Yale to get out of California for a year of graduate school, came back to the womb, and finished my PhD at Stanford in early 1972. And another important fact, while I was a graduate student at Stanford, something called plate tectonics came along. And we were sort of there at the creation. And the whole theory, as you know, had been promoted and codified by marine geophysicists. And geologists were not quite on board until Bill Dickinson, who was my PhD supervisor, convened the second Penrose Conference, GSA Penrose Conference, where I think 80 geologists found out what the three different kinds of plate boundaries and motions could be read in the geological record. It was revolutionary and fun. I was just a grad student showing slides, running projectors, but we came out of that, I think, and then the publications really started flowing about California, the magmatic arc, the four-arc basin, the subduction complex, the Franciscan, which is where I did my PhD actually, in the Franciscan subduction complex. So my work became, let's say, kind of important, as was everybody's who was working on these problems in California. By the way, there was one woman at that Penrose conference, and her name is Tanya Atwater. And she blew us all away by showing us what the San Andreas Fault is in terms of plate tectonics.
What was the year for that conference?
1968. 1968 or 69, I'm not sure, but it was only the second Penrose, and it was in Monterey, Asilomar. That, I think, there were so many geologists who'd done a lot of work, like Marshall Kay at Columbia, who had worked in Newfoundland and the Appalachians, Bob Hatcher, and they thought, oh, now I have a better idea of how to explain this.
Well, I can only imagine the excitement that decade and beyond. Now, you did mention a name that some of our viewers who saw the Merle Beck interview, maybe their ears perked up a little bit. So, Bill, is that the same Bill Dickinson Merle was talking about?
That's exactly the same Bill Dickinson. Yeah, he was my PhD supervisor, and of course I'd known him throughout the rest of our careers. But I should say after my PhD, I went to work for Shell Oil Company. There was a 3-year interval where I was an exploration geologist in the Alaska Division. So I got to go on 3 summer helicopter-supported field projects all over Alaska that a little pilgrim PhD student could never have done on his own.
Right.
And the reason we were there was something called Prudhoe Bay that was discovered in 1968. Shell had worked in Alaska for decades, had made discoveries, but oil companies all of a sudden thought, uh-oh, maybe we've overlooked something. So I felt the pull of academia, and I came to UW as an assistant professor in 1974. No, I think like for my PhD dissertation, it was a rock hammer. I've still got it in the garage. Collecting a lot of samples, looking at thin sections. Dick Armstrong, who was then at Yale, did some K-argon dating for me. But then when I came up here, it was all new to me. I mean, I knew California geology, and my first project, thanks to John Whetton, who was a colleague in Department of Geological Sciences, was in the San Juan Islands. And one of the reasons I was interested is that the Franciscan has some weird rocks called melange. You know, they're mixtures, these chaotic rocks that aren't well bedded, and there was a lot of controversy about how they form. So I went up to the San Juan Islands and I thought, gee, there's some interesting rocks up here, and started mapping, geologic mapping. We used a Zodiac rock hammer, collected a lot of samples. And then I was learning about Northwest geology in the Northwest Cascades. Peter Misch was here, of course he'd worked. And somewhere along the line, I began to think, this is not California. This is not a subduction zone like the Franciscan. You know, these rocks are different. They're widely differing ages that have somehow been mixed together. And this is where I was looking at Bill Dickinson's classic 1976 paper in the Canadian Journal of Earth Sciences, where he basically showed in Jurassic and Cretaceous time California geology right through here and up into British Columbia. And I have a reprint, and I looked at it, and I had a lot of question marks in there. And I think this is something that was very important in when we get to that paper, that Baja BC paper, is that our geology is different, and it can't be explained by just a continuation of the magmatic arc, the forearc basin, and the subduction complex through the Pacific Northwest.
Now, had Dickinson been up here to do the field work, or?
I don't think Bill. All he knew was what he could read, and to be blunt, there just wasn't much written on the Pacific Northwest.
Yes.
You know, we're thinking mid-70s,
Yes.
and compared to California, the burst of papers that had come out after this, conference in 1970s, and so the amount of information was very slim.
Interesting.
And I think I don't know him ever coming up here, although he'd done his PhD in Oregon, in Eastern Oregon. But I think as far as we knew, I mean, our geology here in British Columbia, Canada, I don't think he had very much information.
Okay, well, our main focus is your 1997 Baja BC paper, which is really just, I've reread it a couple of times in the last 48 hours.
I see it down there.
Yes, it's right here. You know what? I should get it. I was trying to piece so much of this together on my own, and then I keep coming back to this thing, and it's truly amazing, Darrel. So 1997, American Journal of Science. You can read the title as well as I. Are Mark and John former students of yours?
Yeah.
Okay.
So I can say a little bit about, we can talk about how this paper germinated.
Yeah.
So we're the late 70s and early 80s. Mark Brandon and John Garver did their master's, and Mark his PhD, I guess master's work on the San Juan Islands. And then let's say 1985, we had a cohort of graduate students that only come together once in a while. I mean, they were all field geologists. They were interested in tectonics. They knew plate tectonics. Mike McGroder, John Garver, Paul Umhofer, Margie Russmore. And because they were working, some of them were working in British Columbia, we would go up to, we knew BC people like Jim Monger, and we'd go to Pacific Geoscience Center, where there was this guy in Vancouver Island named Ted Irving. And we were reading Ted's papers, paleomagnetic papers. And then he wrote a little one in Nature, I think, called, he coined the term Baja British Columbia, as Merle said. So we were interested, and you know, thinking a funny comment, all these guys and women were all proponents of Baja British Columbia. And someone once said, you know, maybe it's the water in Johnson Hall. That's our building and University of Washington has poisoned our minds with this idea. But we all knew about it, and we did our work and everything. And then I think what really drove us to this paper, and it's right in the abstract, Baja BC is based on paleomagnetic data. I mean, Ted was up front about that. Merle himself said it. You know, Baja BC is, and at some point we said, where's the geology? You know, the whole topic is kind of disappearing, because if you didn't accept or like paleomagnetic data for some reason, that was one reason you just didn't have to worry about this. And the other, and I'll say this very openly, I'm a Californian, but I think the other thing is that it doesn't do much for California geology. When you think about it, this is up here in the Northwest, and you know, they've got published a lot, and the idea of having some big terrain move past your state, where we're very happy. You know, we've got I call it the late Mesozoic triad: the Sierra Nevada Arc, the Four Arc Basin, the Franciscan Complex, which, you know, was very happily made during subduction, and then to have this whale move by, I still think that it doesn't solve much for Californians. So that, together with, you know, Mark and John and I said, let's get some geology in here and see not just paleomagnetics. What drove me was the knowledge that our geology here is so different from California. So where did this come from? You look at the paleomagnetic data and you think from the south, and you can't get, I would still claim, I'd go up against that wall and say you can't get the rocks in the North Cascades and the San Juan Islands from the north. But you look south and you can find potential sources for these fragments.
Now, were you the first or the first group to kind of address Baja BC from a bedrock point of view as opposed to the paleomag point of view?
I have to think about this for a minute, but I think the people at the Geological Survey of Canada, like Jim Monger, fantastic mapper and so knowledgeable about British Columbia,
Yeah.
they were coming at it from a geological point of view and said we can understand everything in the Coast Mountains of British Columbia and the Intermontane Belt without having Baja BC.
Oh.
Oh yeah, they from careful mapping and geologic studies, along the all over Coast Mountains, especially the Fraser River area and northeast of Vancouver, Harrison Lake area and everything, over across the Fraser Straight Creek Fault. They would, every time we went up there, we'd hear a conference. We had a little courtier and workshop meetings. They would say, Jim would say, but wait a minute, there are these conglomerates that, so I think they were using geology and did not favor the paleomagnetic hypothesis of Baja BC.
And where were you at that moment, Darrel? Were you totally open, or why were you willing to acknowledge this when everybody else is saying this is just a paleomag fantasy?
It's the water in Johnson. No,
and Peter Mish was drinking that water too,
oh yeah,
wasn't he?
Peter, well, he, he did incredible petrologic and mapping studies in the North Cascades, but he was a good example of someone who, when plate tectonics was invented, a theory, it had some important parts, like three kinds of plate boundaries and movements on a sphere. Peter would say, well, I've been teaching plate tectonics for decades, but he didn't. For him, it was like just thrust faults and not the whole picture.
Yeah.
So he would just say, well, I've been teaching plate tectonics, and I don't think he paid much attention to Baja BC, although he was not very well kind of when all these graduate students and Ted's paper came out.
Mm-hmm.
But Nick, I was thinking, I don't consider myself an iconoclast, who's out to bust major ideas, or I'm not what's the current word, an activist, where I'm looking for things. So I think it was just, we can't just dismiss this because you don't like paleomagnetic data, you don't understand it, and let's do something. This is kind of Merle's comment. He says everybody just tries to disprove the paleomagnetic data and not follow up what some of the implications are.
Yeah.
So I think that was what motivated me. Yeah.
So you had that dream team of students in the 80s, and then we flash forward, if you're willing, another decade. So we're in the mid-90s now, and I'm curious about the specific motivation for that 1997 paper, which essentially is saying, look, can we find some crucial tests so that we can kind of move on, as opposed to just bashing this idea?
I think I actually started writing that thing. I was on a sabbatical leave in Italy in 1995, and I don't know, it'd just been kind of, Paul finished and left, and John Garver finished, and Mike McGroder, and I think it was just sort of a nagging thing. It's disappearing from view. I really felt like let's get it on the front burner again. We don't hear much about Baja BC now, and there's some value there in actually doing some geological tests. But the other thing I was thinking about this morning, a scholar named Naomi Oreskes came and gave a talk at UW. I don't know, she's famous now for a book called Merchants of Doubt, you know, where she basically has thought a lot about the philosophy and logic. And she gave a talk, and she started talking about testing hypotheses. And, you know, maybe, I don't know if she used the term confirmatory bias, but, you know, she says really when people test hypotheses, they're not testing them. They just go out and get corroborating evidence and say, look, you know, I've got more, and they don't consider alternatives. And she might have mentioned a crucial test, which is where you have two mutually incompatible hypotheses that cannot both be true. It's like binary, you know, it's 1 and 0. It could be something in between, but I thought this is really amazing. I mean, we've got two, they both can't be right. So what can you find that each one makes predictions that would, if you find a prediction that's satisfied by evidence that eliminates the other one, then that's kind of a negative test. I mean, you've basically disproven one of the hypotheses. So I think there was just a period of years where we thought it was disappearing, and let's do something geologically. It's a crucial test, and that's where all that stuff in there. I went to the philosophy library and learned about logic and
you know, Richard Feynman in there and J.K. Gilbert, and it was a really interesting way to put that together.
I probably went overboard, but I think it was. I think it's a very common thing that scientists do. I think I've done it myself. Is you have a great idea, and you come up with that inductively. You look and say, hey, I've got this idea, and I'm going to go out and I can find more evidence that supports my idea. But wait a minute, there might be another idea that is not, to use a trite phrase, on my radar screen, you know, so I'm going to support my own.
British Columbia controversy. Did you know Merle at that time? Were you sticking up for this guy? Did you have a collaboration, or was this totally independent?
No, I knew Merle. I mean, we would also have kind of a Western Washington UW workshops every other year, and we'd go back and forth. And no, I knew him. In fact, I was so gratified to see him in your interview because, like you said, he's moved on to other things as I have. Subconscious influence was Ted Irving. I mean, Ted, his attitude was, here it is, you know, I've got, you know, he said, one time he said, you know, all you need is one data point, or, you know, you have data. And I think he was kind of mystified about why people weren't going out and doing things to, he never said, Darrel, why don't you go out and do something geological? I don't remember ever saying that, but I think he kind of published all these papers, and then, you know, with Jane Wynn and Glenn Woodsworth and Randy Inken, and saw that they weren't getting much traction except in his group and maybe from us, but I don't know. I think subconsciously I thought, well, he's put in all this work, and it's a pretty good story that maybe we should, as geologists, we should just go out and help him. I don't know if that's the right word.
Well, you were perfectly set up, I guess if you think about it, with your expertise with California geology, the Franciscan, and that triad. I mean, who better to weigh the differences and to make some connections?
I think that was always in the back of my mind, knowing California and what's possible, you know, that doesn't radically conflict with their good empirical hypotheses and models. I think now I will say this, although I don't know if I felt this, but I think we wanted to give some credit to the paleomagnetic community. You know, you guys have this thing, this hypothesis, but I think we were speaking to the whole community of geologists who worked in the western U.S. Cordillera. I mean, from Alaska to Baja California to Mexico. I mean, you know, we didn't care. We just wanted, because when you start talking about translations of 2,000 kilometers or 3,000 kilometers, you're looking in Mexico. Mm-hmm. And so I think it wasn't for any particular person or group at any university. It was the whole community of we say Cordilleran geologists, who worked not necessarily in Nevada, but the margin. And it was big. I mean, when this idea of terrains came up, I mean, gosh, you'd go to a GSA Cordilleran section meeting, and every graduate students and people would be talking about the terrains in the Klamath Mountains and the Sierra Nevada foothills and up here in Washington. So there was a big group that I think we were trying to I was going to say wake up, but kind of there's something important here, and that's why we put in. I just looked at that this morning. 4 things that you could do, and provenance studies.
What does that mean?
That means there's an interesting sidebar here, but provenance, when you look at a sandstone and you look at the sand grains, you want to know where all the minerals came from. The provenance is source. So we said the provenance of the sandstones in the Methow Basin. That's over east of the Cascades, and it's got beautiful stratified sedimentary rocks in it. And if you study the sand grains, you might be able to figure out where were they eroded from, next door or somewhere else. And the Nanaimo, which is this fabulous Upper Cretaceous, very thick section in just a little bit in San Juan Islands, but in the Straits of Georgia, Nanaimo, beautiful sandstones. Look at the sand grains and see where they came from. Did they come from the Coast Mountains in British Columbia or somewhere else? And John Garver, one of our colleagues at UW, Joe Vance, had gotten interested in dating zircons, the mineral zircon, which is a detrital mineral, little grains of zirconium silicate, using a fission track method, to try to figure out the age of the zircon. And John Garver was all over this. He did this in his master's work. And so he might have been the one who said, well, let's think about Precambrian zircons, because in that paper there's a map of Precambrian basement in North America of widely divergent ages, 2.5 billion up in Wyoming, 1.4 down in the Mojave. And we thought, wow, if you could find zircons in the sand and date them, and they're Precambrian, you might be able to figure out where along them, because the ages range from older in Wyoming to the north to younger to the south. There you go. There's your kind of so that's why provenance, studying the detrital grains, came in. And I think there's also one about, well, can you match rocks from, let's say, eastern Washington or eastern British Columbia right across all these faults, and there's a pinpoint, where you can say, hey, that rock unit on Vancouver Island, the San Juans, is so like one over here in the Okanagan Valley that it can't possibly have moved great distances. So we kind of put some ideas out there for people to pick up on. So
how would you characterize the reaction to the paper? Was it immediate? What did your former advisor, Bill Dickinson, have to say? He was one of the most vocal critics of Murrow.
The paper has been cited a lot, so let me say that it's visible. I mean, the community knows about it, And I think one thing it did do was, and it might have taken a couple of years, is there were some geologists who picked up on the detrital zircon story, and that was Brian Mahoney and Peter Mustard. And Peter was at the Geological Survey of Canada, and they got some detrital zircons. I think it was out of the Nanaimo, and with a limited data set said they came from Montana. So, you know, they said that rules out Baja BC. But then Bernie Housen and Merle wrote a paper and said, wait a minute, you know, there are other places these zircons could come from. And that's one of the, we get back to confirmatory bias. You always look for evidence that will support your idea. And zircons, number one, can get reworked. You know, they can be deposited into a sandstone, and then that can be reworked, eroded, and reworked. But the other possibility for the limited data set is Southern California. You know, which people are working on and thinking about. So, to get back to your question, I think the paper is well known. For a while, nothing really happened, you know, except for maybe the limited detrital zircon work. But and this is 1997. Detrital zircons were kind of a new thing back then. I mean, but now, I mean, everybody does them. So the study of detrital zircons and trying to figure out where they came from, that has really taken off. But it took a while. It took 97, I mean, basically, you know, 10 or 15 years for that to happen.
Well, I was thinking about this on the drive over. I was talking to Merle. We're approaching 50 years ago that the original idea was out there.
Yeah.
And roughly, we're talking about 25 years ago that
Yeah.
you're doing this kind of, you know, hey, let's not forget about this thing and let's fire some people up. So there was a little delayed response, but the detrital zircon group started to find some things, or there was both camps of detrital zircon people.
Yeah, there are, you know, it's interesting, we're 50 years out, and it's still like an interesting hypothesis that is not, it's just not very prominent, I think. This is, you know, so the detrital zircon work, and we have like a Seattle GSA meeting, we had a symposium, Portland, you know, there was information presented, but pretty soon it's like you're speaking to a pretty small audience and not the broader Cordilleran community, which is what we were really speaking to.
I'm surprised because I guess as I've been trying to put things together and acquired kind of collected papers from the last 5, 6, 7 years, and certainly that session you put together in Seattle, I mean, that pumped me right up. I was like, boy, I gotta spread the word about this. We've crossed a hump or something like that.
Yes.
But maybe it doesn't feel that way to you. You've been in it so long, or maybe did you say you've kind of backed away from it too?
No. I think I'll make a couple of other comments that in addition to let's say the Provenance studies, there is some paleobiological evidence. You know, leafs in the Methow Valley in the Middle Cretaceous sediments that Miller, Brandon, and Hickey worked on, you know, from the leaf margins and everything, made a case that they were deposited farther to the south. I think Peter Ward has some data on ammonites, and he presented that at the Seattle meeting. So there are other lines of evidence, and I also want to say that it's not just Baja BC, but if you just look at geology, I've published on this idea that this skinny little terrain in southern Alaska called the Chugach Prince William terrain, that its southern end on Baranof Island was just sitting off Vancouver Island 50 million years ago. I published that in 1983. That's geology.
Did you really?
Yeah, and I republished it in 2003. It's called the Chugach, or the Baranof Leech River hypothesis. You know, that again, it's a skinny thing, and there are the faults. That's the other thing. You know, people say, where's the Baja BC fault, like Merle said. Well, you know, that's 80 million years ago, and a lot of things happen to faults. This is post-50. And then the Yakutat, this little terrain up there that everybody agrees is slamming into the Gulf of Alaska, the armpit of Alaska, and it had to travel maybe from right offshore here. It has a piece of Silesia in it, this crescent basalt. So there are other geologically based hypotheses for transport, and I don't know. I think maybe the community's more interested in low-angle normal faults. That's my current research. I mean, I haven't abandoned Baja BC by any means, but I'm not doing any more field work that is relevant to it. There's a group. It's Ken Ridgway and his students, Jeff Trop and others, who are working in central Alaska, kind of south of Denali, and they have studied the rock units, and the Denali Fault goes through there, and this is the northern edge of Wrangellia, and there might be more work, detrital zircon work. I don't know about paleomag. As Merle said, paleomag, we've plucked all the low-hanging fruit, you know, like the pears on my little pear tree there. So I think in Alaska, maybe that part of Alaska, what I would like to do is, like I've said, I think that the rock units in the San Juan Islands and the North Cascades, they're different ages and they've been juxtaposed along contractional faults, came from the south, but I don't know where. You know, the problem is they might have all been clipped off and carried up here. So it's hard to say. You know, where are other places that we could? I think we need to better characterize the potential sources of these detrital zircons, and I might make one comment that you know, if we want to derive them from Idaho 80 million years ago, that's 80 million years ago, and were the source rocks actually exposed 80 million years ago? In fact, we have Allison Duvall and Basil. There's a group with their students who are looking at the formation of the middle fork of the Salmon River, and this nice thing happens to be right there, and they've collected a lot of samples for thermal chronology to find out what the burial and exhumation history of this area is. So I think some interesting data are going to come out there about the possibility that this thing was exposed. And then let's go to Southern California, the desert. What did it look like 80 million years ago? You know, was there a source for these two particular peaks of Precambrian zircons 80 million years ago? I mean, today, this is 2020, and it's very difficult to reconstruct what something was like in most cases 80 million years ago, unless you're in Kansas. You know, I mean, then a lot's gone on out here. So better characterization of the potential sources of these zircons, I think.
So that's a look ahead to the next decade, possibly more zircon work, better refinement, better techniques, any other. I mean, it's impossible to brainstorm approaches that don't exist yet, but any other glimmers of hope to push this ahead? Or do we need another Darrel paper, another like crucial test paper, like another kind of, it's 50 years, let's regroup, and where are we now?
Well, I think what we chatted about earlier, that Basil Tikoff and Paul Umhofer and I, it might be just a refreshing people about the idea of oblique motions in the Cordillera for 100 million years to the present time. And if you can say, wait a minute, Basil calls it a new paradigm. And wait a minute, if you can say, yeah, that's, so what is oblique movement? What does that entail? Rotations, you know, and translations, strike-slip faults. And if you can accept that as the I won't say dominant paradigm, but a very productive view, then I think you won't have to write another paper like this. Then it might bring more people into the out of the minority. I don't know. It's a tough thing.
Well, this has just been great. I want to make sure to plug your book, and then anything else you want to add is great, Darrel. If Darrel's name sounds familiar to you and you can't quite figure out why, here's why. Darrel and one of his former students, Marley Miller, have put together a beautiful second edition of Roadside Geology of Washington. It's got this cover, so if you've got a yellow cover, that's the first edition. That's not these guys. And Marley also did a second edition of the Roadside Geology of Oregon. Hey, I didn't see a whole lot of Baja BC in this book.
Oh, there's a little bit. I think there's a little bit. I say there's a controversy. I think it was in the part on. I wrote the introductory parts to the provinces, like the Coast Mountains, and for the North Cascades and San Juan Islands. I think it's in there, but not. I was careful about that. I'm not going to proselytize about Baja BC, but I did say there's a controversy.
Well, that's what I'm curious about. It feels like people that have heard of it are hungry to learn more, and I guess it was your choice to. I don't know if conservative is the right word, but you're like, let's just look at the rocks. Here's the mile marker, such and such on State Route 20.
Yeah, I know, it's pretty. But reading the comments after Merle's interview, people put in. I was really gratified how much they enjoyed not only him, but he's a great person to talk about this, but also the whole idea and like you picked up on it and got excited at the maybe I'm misreading the community. Maybe there are a lot. I don't
think so.
This is one of the first 1997 issues that had color in American Journal of Science. There it is. And
you want to show us one of those?
Well, I don't know if you have the yeah. So one of the things. Well, I guess what I was really proud of was hypothesis A, which is basically what it looked like 90 million years ago is what it looks like today. And then B, which is just moving things back totally according to the paleomagnetic data. But there are the two. There's Baja BC, there's California, and you got to slide this thing past until it gets up to the north. So those were fun to make those. And then we also had stuff in here about this
so well done.
The geology of the Pacific Northwest. There's the Fraser River Straight Creek Fault and Coast Mountains and Vancouver Island, but also the introductory parts are a review of our geology here, and I think that was a chance to kind of do a little synopsis and get it into a paper, hoping that people would read it and recognize some interesting differences here.
Well, I got you here then. So
yeah.
What are the four? You mentioned a couple of them casually, but maybe back to the abstract or something. If you've got the four, you kind of had your okay, troops. Here's what needs to happen.
The provenance of detritus in mid-Cretaceous strata in the Methow and Tyotin basins. So Tyotin is the northern, the Canadian extension of the Methow basin, which has a beautiful section of lower Jurassic up into mid-Cretaceous stratified rocks. There have been paleomagnetic studies there, but they couldn't pass the fold test, I think. So we don't include those in our. So you want to look. The detritus means detrital zircons.
Yeah.
You want to know if they came from the Okanagan batholith to the east, or as I think we proposed, the peninsular ranges. They would have been sitting off Mexico and come from the peninsular ranges.
So still mixed results depending on who you talk to.
Well, actually, Kathy Surplus has done, people, including Kathy, have done detrital zircon studies, and she would make the case for the Okanagan batholith, but but I've looked at, I think you can also derive them from plutonic rocks in the south. I've never published that, but again, it's, look a little bit more broadly.
Yes, right.
And then here we go, late Campanian strata in the Nanaimo group. Okay, that's being worked on a lot with the Calgary group and early on by, as I said, Brian and Peter Mustard. Mm-hmm. Offset geological features in Baja, British Columbia, matching counterparts in southwestern California and northwestern Mexico. So can you find, if you look at rocks up here like the Shuxon, or can you find the parent where these orphans were derived, the parent down there, make a match? You've got 2 points, you pinned it. These are like pinpoints or something. We haven't done that yet.
Haven't?
No, because the problem is that they might have all been clipped off and they're now up here. You see what I mean? It's kind of a, let's say that all these units in the San Juan Islands and the North Cascades did come from northern Mexico, northwestern Mexico, and nothing's left. I mean, they were accreted and they were added down there, and then they were carried up along in this oblique margin up to kind of a resting place here.
Well, what's this business about the Swakane gneiss near Wenatchee and then the POR schist down in Southern Cal? Is that matching bedrock, or is that more of a zircon?
Well, it's interesting. I looked at I've looked at the Swakane a little bit, and I've also looked at the Pelona Orocopius schist. I grew up there. It's in the San Gabriel Mountains, and when I first heard that the Swakane might be Pelona Orocopia, I thought, wait a minute, the rock types are kind of different. The Pelona Orocopia has chert, has ultramafic bodies, and they're very, very rare in the Swakane. But I mean, these units could change along strike and everything. So I think it's the zircon data are pretty compelling. And no one would argue, I think, that Pelona Rand Orocopia was not deposited right where it was, subducted very quickly, and then exhumed right there in Los Angeles. So this is a paper by Kirsten Sauer and others that said, this is pretty, I learned a lot when I read that. I thought, or I got a preprint, I thought, oh, that's pretty darn neat. Yeah, I think that's basically a geological match. You're not going to get paleomagnetic data out of any of those things. But so that paper, I don't know if it's had much of an effect. I mean, we read it, I read it, and Paul Umhofer reads it, and then
there could be more of that. There could be more of that matching of rock units.
That's right, yeah. In fact, John Garver, he and Cam Davidson have a paper they're working on about the Yakutat group. And they found some very interesting comparisons of what's in the Yakutat group, which is what's over here in the Cascades called the Western and Eastern Melange belts. I don't know, they're mysterious units that nobody talks much about, but John's very good about again, that's matching up rock unit up in Alaska with something that's right here.
Give us a location here that would work for that eastern or western.
Yeah, I'll tell you. I was
Mount
just
Si
up there. I was just up there twice. Mount Si, the Sultan Basin, the South Fork of the Stillaguamish River, all the way up to basically what I think Roland Tabor called the Darrington Devil's Mountain Fault Zone. So it's this, Mount Si, Stillaguamish River, west of the Straight Creek Fault.
Yes.
West of the Straight Creek Fault. It's very poorly exposed. I mean, I went up and actually there's been some detrital zircon work there. It's a mixture. It really is. a mixture of all kinds of stuff in there. And I went up and collected a sample that hadn't been studied for detrital zircon sandstone, and I asked Stacia, and I'll send it to her, and she said, well, we'll just crush it up and see if there's any in there, and then if there are, you can go back and collect some more. But again, that's a match. That's like my matching of southern tip of Baranof Island with the Leech River schist. That's the unit in southern Vancouver Island. That's geology.
I mean, that's the most satisfying from a teaching point of view, and maybe for the skeptics as well. If you can blindfold somebody and take them to Mount Si and Chugach and say, show me the difference.
That's a good point. I think if you, I think the Leech River Baranof hypothesis has gotten a little more traction because it's basically two rock units that have had such a similar history as young as 50 million years ago that it'd be, I mean, it could be a wonderful coincidence, but I think, and given the presence of major strike-slip faults in Alaska and some paleomagnetic data, there are a couple of paleomagnetic sites in the Chugach Prince William terrain that date from the 80s, early 80s, that show, and Bernie Housen and I think Sarah Ruskey have a couple of unpublished dates, so I still think that's a great idea.
Yes.
Yeah.
We're getting there.
Baranof Leech River. Yeah.
Well,
number 4. Let's see. And late Cretaceous or older features limiting offset across the transcurrent Baja BC fault to less than 1,000 kilometers. So we hypothesized there has to be a big fault, like the Pasayten fault, and or the Coast Shear Zone in Alaska. And if you could find something that, this is what Jim Monger would argue, we can do that. We've got these conglomerates in the Cretaceous that are present on both sides of the fault, and that's a pinning point that would limit to the displacement to much less than 1,000 kilometers. I also should mention that Paul Umhofer, early on in the late 80s, and others, I think it was Sandra Wild, added up all the slip along all the faults from the Tintina Trench all across British Columbia, and they can come up just with what we know about the faults with 1,600 kilometers of slip like that. So there again, that's geology. I mean, you're not going to say those faults don't exist, and we've got numbers. So when you do a purely, Paul will still stand by that, when you do a purely geological reconstruction, 1,600 kilometers puts it pretty far south, off California basically, not as far as 3,000 kilometers. So
that has to be the minimum offset for any discussion.
Exactly.
And people still insist?
I don't know. I don't know. I would ask Paul. I'd say, well, all right, I'm going to ask you what Nick asked me.
Yeah.
What's the reception? What's the reaction?
Right.
You know, what do you hear from people? And I kind of think he would say, well, I don't know. I think it should have more, get more traction. But I don't know. I want to put words in his mouth.
Well, yeah. Well, that's probably enough for today. Thanks to Darrel for his time. Thanks to you for your time. Hope you're continuing to have interest in this Baja BC concept, and we'll continue to build on what we can learn together. I love you. We'll see you next time. Goodbye.